Welcome to today's Deep Mining Cross-Sector webinar, an opportunity to hear about how different sectors outside of mining, industries outside of mining, can help us address this deep mining challenge. We'd like to begin, as always, with an acknowledgement of country. We acknowledge and pay respects to the traditional custodians of the land and waterways which we work from today. For me, this is Whadjuk land, the home to the Whadjuk people, Noongar people. We pay respect to elders past, present, and extend that respect to Aboriginal people and Torres Strait Islanders here with us today. Today's speakers, you'll have myself hosting throughout, and we have three internal TAD speakers giving us insights: Michelle from the space sector, Andrew from the civil sector, and Michelle from the oil and gas sector, speaking to their experience and what they know about these industries, given their expertise. We'll also fortunately hear from some external speakers too, giving some insights from innovative perspective in Clyde from Intelligent Robotics and Matthew from EcoHoist. So really excited to hear. Today's agenda, we'll do a welcome and introductions, which I've just gone through now. Do an introduction to the TAD team and the joint venture and the joint venture members part of TAD. I'll then go through an introduction to the Deep Mining Challenge and speak a bit more to this cross-sector approach. Then provide some industry insights from the three TED speakers I mentioned earlier, and then some innovator insights. And then we'll open the floor. If you have any questions, then please leave them to answer at the end. BHP covers three assets predominantly: copper, iron ore, and potash. The Deep Mining Challenge is quite closely linked to BHP's copper assets and unlocking low-grade copper. And the Think and Act Differently team is the innovation hub within BHP. Their predominant role is to find technologies that can help accelerate the unlocking of some of these assets, and copper, potash, and iron ore in particular. So they help deliver these technologies and insights, particularly from multiple sectors, and bring them to the BHP funnel. The way that the TED team do this, we help innovators with their technologies. So by helping funding with proof of concept experiments all the way to demonstrations on various sites, using a value chain approach to foster the flow of these technologies and empower BHP to meet their needs today. And they often their superpower is the innovation ecosystem. So this is all around bringing different innovators together, working in similar domains, similar problem statements, particularly with their varied expertise, to collaborate with a range of individuals and help accelerate their technology together and collaborate together. Now hand over to Michelle to speak more about the joint venture.
Hi everyone, how are you, and welcome today as well. I'm really excited to share a little bit more about the joint venture. This was created in 2022. It was up and running last year with 5 different partners in total, including BHP, and we've recently just brought on 2 new JV partners, Eramet and Agnico Eagle. Basically, these organisations come together really so that they can share in risk and share in investment in helping to advance technology for our sector. Really, the focus is on reducing water waste, energy and emissions, but the focus that everyone has also flows over to deep mining, with operations contained in each of the companies across BHP, Rio Tinto, Boliden, South32, IGO, Eramet and Agnico. They all have different commodities, but deep mining is all part of their future. And so they're also keen to hear what people have to help unlock some of the future assets for them, but also to help support some of the current operating assets. The way that each of these companies work is that they will help to assess the different companies that come into the challenge. They'll help us select, and they'll also help us with refining the scopes. These companies will then choose themselves which scopes that they want to be a part of, and put money into those. So it really is a collaborative approach whereby we share insights, we share learnings, both in the upfront design phase and then in the final phase of testing and experimenting. So really exciting that we're working with these mining companies across the globe, and that this offers also innovators and technology companies the ability to share what you have with them as well.
So the Deep Mining Challenge is all about helping us unlock the value of deep critical minerals, particularly those at depths greater than 2,000 meters and related to BHP's assets, particularly across South America and in Australia, particularly Copper SA. We launched this challenge in early September. The round one part of this challenge closes in just under 2 weeks. So we're splitting up the review period to enable a lot of submissions to be fast tracked through, particularly before the busy December holiday period. But then we will officially close out for all submissions on the 26th of November. One thing to note with this challenge is we're eager to hear all TRL ideas, whether you have just a concept idea, research concept idea, up to an established product. We're eager to hear from you. And whether, expert innovators from any industry are welcome as well, not just within mining. So what exactly is the problem with deep mining? So particularly at some of these assets we spoke of and at depths greater than 2,000 meters, there are high horizontal stresses, particularly as a rough crude figure, twice that of the vertical stress regime. There are high temperatures. Rock temperatures increase about 30 degrees per kilometer you go. And hypersaline conditions, obviously causing corrosive conditions, particularly for the ground support that holds our tunnels up. And then long haulage distances, which poses lots of collateral issues and problem statements. The current mining methods in a lot of BHP's assets are between the underground assets span from block caving to long hole stoping. And these conditions with deep mines impact our ability to perform this mine method as efficiently as possible. So to explore those issues and impact, here are just a couple of examples of what they lead to. So obviously the high horizontal stresses, higher likelihood for rock bursts and unstable tunnels. Also, as you're trying to bore holes, they're constantly collapsing. The impact this has is our ability to continuous develop tunnels, particularly at these depths. It's worth noting too as well that also interrupts our ability to have good drill platforms and platforms to put sensors to collect more ore body data, which impacts our ability to follow and plan accordingly and create an efficient mine plan. Higher rock temperatures obviously create humid environments. Machines don't like this as moisture gets into component parts, impacts our ability to operate safely. Hypersaline conditions creates corrosive environments for ground support, and that also impacts our ability to mine safely. And long haulage distance make traditional material movement techniques, such as load and haulage with trucks and loaders, more and more difficult, impacting our ability to be productive and impacts our ability to plan effectively. So how do we solve this? So how do we work through these challenges? Obviously, the mining industry is adapting within itself, but one key way that the TAD team and BHP more broadly are attacking this is by bringing relevant industries from outside of mining, bringing them in to build an ecosystem of people to help solve these challenges together. As you can see on screen, there's quite a few industries that we've placed here that we think are very cross-compatible. I have technologies that you can see here and capability that is cross-compatible to some of these deep mining challenges. Obviously, they're not limited to these, and we're not experts in these fields, so some of our terminology that we've listed here may not be as accurate as an expert within each of these respective fields may have. But today we're specifically going to speak a lot closely and intimately with space sector, civil sector, and oil and gas sector. So to flow on nicely from that, I'll hand over to Michelle to speak about the space sector.
Thanks, Sam. So I've got a couple of minutes here, but I guess I just want to touch on a few points in which, or a few areas in which we think that there are overlap and therefore where we would love to see companies operating in the space sector that might wish to apply to this challenge. If you look just at the very basic level, everything that we do in space, whether it's on orbit or whether it's on the moon or Mars, is all done robotically. It's not done with people, and therefore, we think that the smarts behind automated equipment, automated, flight paths, the different types of operation on any kind of satellite or rover or other fixed asset or mobile asset, is designed in such a way that, we would love to learn about how do you go about the design, how do you think about the operation itself so that you can be in a position where you have 0 people in place. When we think about the depths that we have, and even the way that Sam described the environment, in many respects, you could have been describing the space environment. And so in particular, robotics companies that are focused, as I said, either on orbit, lunar or Mars would be of great interest to us. I think the other thing is when you're developing these assets, as I mentioned, they are for remote operation. And so you design that in such a way that you don't have to be maintaining this with people. You don't have a fallback. There is no plan B if something breaks down. You also design the space logistics to be able to come and repair a satellite, for example, or you design the robot to last a longer time. And so these are some of the considerations also that we would love to learn about, that could be integrated with an OEM. It could be integrated into specific assets that do different ancillary functions or even primary functions, both in the development of the original excavation or even in the extraction of ore. I think the other thing with the environments in space is that comms is hard, navigation is hard, and so in GPS-denied environments, you have to solve for that to operate your assets. When we start to get to depth, we've continued to evolve what we do with comms in the underground environment, through LTE and beyond. But we'd love to look at, is there an even smaller footprint for infrastructure, a much smarter infrastructure that can be a backbone for us to continue to grow more and more robotic assets in the environment that can enable us to have more robots and sensors to be able to do the jobs that otherwise would have used people for in some of the high risk environments. The other area is sensing. So when you're operating remotely, I guess for lunar or Mars environments, you're setting up different mineral sensors. You're also detecting what else is going on in the environment so that you've got some kind of awareness or understanding around your asset. We know from some of the Mars rovers, LIBS has been deployed to be able to look for different minerals in the subsurface, and LIBS is now kind of used pretty widely, particularly in the lithium sector. So we'd love to understand, whether there are some sensors that you've either deployed or that you have design over, miniaturized sensors that we could otherwise deploy. It could be on a robot, could be on a drone, could be fixed to some kind of vehicle. But how could we start to learn more about the ore body as we excavate or create kind of tunnels towards the ore body, and then every day within the mining operations? We really think that the advancements in the space sector around both the resolution capability of sensors as well as miniaturization is something that we would love to have that insight into and effectively be able to tap into the investment and the technology development happening in the space sector every day. And lastly, one area I think, we know that in the mining sector we don't do very well is simulation, both in design and mission planning. And so what we can learn from the space sector and how you use simulation, you design for multiple scenarios, both with people and with different tools to be able to play out alternate futures to help with design and to have really efficient operations is something that we would love to be able to, again, kind of learn from, tap into, look at how we can deploy both the capability and the technology into our own design for deep mining. That's probably all I have to say. I guess there are kind of a few highlights of what we think is obvious kind of crossovers, but there are probably things I haven't captured, and so I think if you're operating in the space sector, both your knowledge, the way that you design and technology is all of interest for us to really think differently about how we operate in deep operations. Thanks, Sam.
Thank you very much, Michelle. I'll now hand over to Andrew. Hopefully he's been able to join the line to touch on the civil sector.
Welcome everybody, and thank you, and thank you, Michelle, for some fantastic insights on the space side. So from a civil engineering perspective, this is I think an area that I just wanted to sort of talk about from just the number and size and some of the difficulties that the civil engineering world has had to overcome. So and there's a lot of, I guess, spectrum of civil engineering. So what I'm going to really be focusing on is more around the vertical development and the horizontal development. So tunnel boring and shaft sinking is the sort of two areas that I see there's plenty of opportunities. But it's also the level of execution. And so if you look at the number of mining projects as a whole, there is a significant number in comparison of engineering projects. So it's really a matter of scale and number of projects in execution at any one time around the planet. So what that means is that there's actually a larger group of people that have got experience in this area, but it's also something to note around the way in which the projects are executed. And so I think there's a lot of opportunities to leverage from the civil engineering world, especially around the speed at which tunnel boring takes place. I think there isn't a capital city around the world that doesn't have a tunnel underneath the city at some point. So the sheer volume of the amount of tunnels. And so what that has, I guess, what I've seen is that the speed of development, as in more technology development, has been significant. With regards to that sheer volume of projects. So what we're seeing is there's a high precision in survey control, in ground support, in continuous build of not only building the tunnel but building out the aspects of the tunnel with all the ground support in one go. I think there's some lessons and some opportunities for us to take advantage of some of the suppliers, some of the contractors that operate in that space, but also the ecosystem that is around the construction and civil engineering world with regards to the sensor technology, but also the material movement, moving dirt out, but also bringing infrastructure and components in. So I think that's probably the key things I wanted to highlight. In terms of the vertical development, though, one thing that's interesting is the types of environments that vertical shafts have had to go into, especially when we look at some of the construction projects in like mountainous terrains. And so there's some interesting capability that I think we could be, we'd love to tap into. The ecosystem that's supporting some of the vertical development and projects around energy storage. So there's a wide range of pumped hydro storage projects underway, which is constituting a lot of not only vertical development, but also cavern and void construction. And there's some interesting projects underway with actually using weights as so gravity energy storage. And so the number of projects that are starting to pop up around that topic is also really, really interesting. And so I think that the ecosystem that supports the civil engineering world and the way that they construct and execute projects, because the margins in civil engineering are actually, when you get into it, are actually quite tight. And so there's a inherent a need to be as efficient as possible, and even to be as innovative as possible. And so I think there's a great opportunity to tap into. So if anybody on the call knows of any company that's working for providing any technologies into the civil engineering world, please direct them towards this challenge, because I think there's a lot of opportunities to be leveraged and to be taken to really be applied here. So yeah, with that, Sam, I think that's all I really wanted to highlight. Back to you.
Great, thanks, Andrew, for your insights. Lastly, I'll hand over to Michelle to give us a rundown of her experience and some insights from the oil and gas sector.
Hi, everyone. Yeah, I spent 22 years in petroleum, and I've now been just under 4 years in mining. So clearly, I believe there's a lot of opportunities to transfer knowledge and technologies between our industries. Both of our industries are kind of fundamentally built on understanding geology and the rocks beneath our feet, and how we extract resources from that geology. We also all work in remote locations, perhaps not quite as remote as space, but we do have a common interest in exploiting those rocks at as low as cost and as responsibly as we can. So I'm sure Sam talked to this, but the mining industry is undergoing a bit of a paradigm shift right now. The industry was built to mine shallow and quick. And as we move to greater depths, we're having to think differently about how we can obtain ore body knowledge and how we can make the right decisions earlier in the processes about how we are going to extract that ore. And it's getting more expensive. So we're drilling at 25-meter centers, and coring every drill hole or well top to bottom was feasible for shallow deposits. Obviously, as we get deeper, that is increasingly unsustainable. And this is a world that the oil and gas industry has been in. That is the oil and gas industry world. Drilling deep, getting as much knowledge as possible from that drilling, and making early decisions based on the optimizing, how much we drill, how much we spend, and how much knowledge we can gain from that drilling. It's also looking at where the oil and gas industry moved to with onshore drilling, and some of the drilling technologies around drilling deep, but also massive horizontal holes and side tracking technologies that aren't that hasn't made it fully into the mining industry at this point. And also that the whole concept around how would we drill to test a model. So we build a model of the earth and an understanding of that, and then drilling to test it, rather than drilling at 25-meter centers to define that model. So there's a whole kind of paradigm shift that the mining industry is starting to appreciate around how we get to this. So drilling technology, so ore body knowledge and how we capture those models is one area that I think would be really interested in hearing more around. Drilling technology, hot, in the context of mining, we're talking, 80 degrees plus. That's not hot for an oil and gas well. So the technologies, the tools that we use to understand the subsurface, the way we can cement drill holes, the way we can case and manage stresses. These are bread and butter kind of situations for the oil and gas industry, and things I think that we'd be really interested in learning more about. Fully acknowledging that in oil and gas, the vertical stress is the primary stress, and in mining, it's often horizontal stress. But obviously, things like the learnings we've had from salt and understanding salt shear and drill holes are potentially transferable. And then obviously, we're already starting to look at technologies such as seismic and downhole acoustic fiber and things like that that can help us to sense and monitor the subsurface at depth. So most of the mining geophysical tools start to kind of lose their power at 200 or 300, 400 meters depth, and so adopting some of the mining approaches to that is really interesting to us. And also just, like we've said in both civil and space, sensors, tools, approaches for remotely operating assets in challenging environments, and where we can come together on that. So these are some of the things that I have in mind, and I'm sure the group on this call has a lot more ideas being sparked by this conversation, and I'm really excited to hear whether those opportunities may be.
Awesome. Thanks, Michelle. Now on to some innovative insights. So I'll hand over to Clyde, Director of Intelligent Robotics, to chat to us about a couple of innovations he's worked on previously and addressing problem statements in mining.
Thanks, Sam. Yeah, our company, Intelligent Robotics, focuses on how to use unstructured space, whether it be vision, sensing systems, radar, X-ray, and then turn that into structured space to do something with a 6-axis robot. Normally quite varying tasks. In mining, this has taken us down the track of robotic refueling of mine trucks, where your truck would come into the refuel station, driver stays in the cabin, the robot would sense where the fuel tank is, take the cap off, fill it high flow rates, like 1,500 litres a minute, then put the cap back on and let the truck drive away. The one on the right-hand side here, the image is underground in Australia, doing robotic idler change. So the system itself would allow us to be able to bring a truck underground with the belt completely running, sense where we are in 3-dimensional space, lift the belt up in full operation, and then allow the robot to be able to come in and pull the idler out while we're in full production at full speed on the belt. That allowed people like Newcrest to be able to not shut belts down, to be able to change idlers. So it's a quick video that's just showing you us lifting the belt. Then the robot goes and takes the damaged idler out while the belt's in full operation. So our sensing systems in this one are 3-dimensional. We're continually cross-checking ourselves to make sure we know where we are in 3D space. And remove the idler, replace the idler, and put the belt back down without turning any of the production off. Yeah, well, where do we see ourselves adding value to the mining industry? Really taking operators out of dangerous areas, improving uptime and mining assets, and automating mining maintenance. And it's a matter of where do we use our technology that we've already got deployed in other industries and bring it into the mining industry. So I'll leave it at that, Sam.
Great. Thanks for that, Clyde. And really great proven examples of integrating into problem statements within mining and creating a tangible outcome. Now hand over to Matthew to chat to us a little bit about EcoHoist.
Hi, everyone. I'm Matt from EcoHoist. We think a bit about the material movement challenge in deep underground mines. And so something that we've realized is that most mines use diesel trucks to move material to the surface, and only some mines use hoists. And so trucks have associated diesel, CO2 emissions, and high operating costs, whereas hoists are electric, automated, and have a low operating cost. And for those of you who don't know what hoists are, imagine a bucket on a rope down a hole. So in light of this, what we asked was, why don't more mines use hoists? And onto the next slide, please. And so we believe the reason for this is project capital cost. And so traditional hoists involve the use of large diameter mine shafts, usually from 6 to 12 meters in diameter and costing in excess of $100 million. What we've come up with EcoHoist is a solution that can use 2 small mine shafts of about 1 meter in diameter. And that means that they can be drilled instead of sunk. It means that we can use sort of directional drilling and or raise boring to drill straight shafts that we can install the continuous conveyor into. And that brings the overall project capital cost down and reduces the barrier to adopting clean and efficient vertical hoisting. So we've recently received the results of an impartial study investigating an eco-hoist capable of 2 million tonnes per annum from 1,000 metres deep. And this indicated a net present value of $122 million for the potential customer. So thanks for the opportunity to speak. I'm Matt from EcoHoist, and we are optimising and decarbonising deep underground mining.
Great, thanks for the insight, Matt. So as a result of all this, what kind of solutions are we after for the deep mining challenge, and how can you get involved? As a result of all of the key problem areas that we touched on earlier, we've summarised 4 key areas that we're eager to explore. So different ways of excavation, access to ore, given the challenging environments, different sensor challenges, particularly those that can help provide us better geotechnical ore body knowledge, things like that. Situational awareness at depth, so that different devices and machinery and operations can be maintained effectively. And then material movement, which we've heard of some great solutions from some of our innovators here today. So what kind of ideas are we after that attack these particular areas? We're eager to explore things that are either small incremental changes that can be integrated into existing systems, existing mines, or whether it be transformational changes, so completely new ways that we look at approaching deep mining, particularly to echo Michelle Thomas's point around how mines were particularly built to tackle shallow conditions and do it quickly and effectively. The deeper we go, the harder it is to use these systems at depth. So transformational change is definitely something that we're eager to hear about. Speaking to some innovators throughout this process, particularly those in the geothermal sector, we've heard a lot about new business opportunities arising out of cross-compatible technologies for in-situ recovery that some of these businesses hadn't realized were a potential market for them to explore within mining. So it's these kinds of conversations and workflows that we're really after, and keen to connect and chat about these things. To get involved in the challenge, join here, scan the QR code, or jump onto our website. And if you have any follow-up questions about the challenge or how to get involved, whether you just want to participate and learn more about the challenge, or if you have something that you think is worthwhile submitting, or any questions about this submission process, feel free to send us a message and we'll eagerly get back to you. Now, pass on for some Q&A toward the end, and feel free to ask questions to any of our internal and external experts as well. I think we had one in the chat earlier from Christo. Are there particular references as to the generic layout and excavation sizes currently being used, considered for these mines at depths? Feel free to ping us afterwards, but a lot of this information is available on BHP's website, so particularly in Australian assets and South American assets for their underground mines. We're also providing a data room for those that submit to the challenge, and those that are selected to progress will be able to access particular bits of geological data and geotechnical data that will obviously be provided after signing an NDA. Any other questions? Feel free to jump off mute if you want to ask as well.
There's one in there around mineral processing, so underground processing. So.
Yeah, we're looking at different. Definitely interested in any kind of ideas at these depths, particularly mineral processing. Can be assessed. It's not a primary area that we're looking to explore, but particularly those that can attribute to new ways that we move material to the surface. Yeah, we are interested to explore this.
Yeah, and look, I see a question here or a comment about oil and gas having a much better track record of probabilistic decision making than mining does. And I think that is absolutely true and a reflection of the level of certainty in the models as well coming into oil and gas, where maybe, especially offshore, where you've maybe got 5 drill holes before you start designing the entire facility and committing, significant capital to moving something forward. So it's been a necessity. And I think the mining industry can learn from that concept of, how do we drill to reduce that uncertainty and to appraise a model versus drilling to set every exact parameter within that model. So I think that's a really good call out. So in answer to the question around do we have resources at depth identified? Yes, we have existing deep mines. We have extensions to our current mines, which are getting increasingly deeper. And obviously, if you look at the exploration space, those mines, the target, all of the shallow stuff, or a lot of the shallow stuff that's accessible has been found. And much like everything else, the questions are getting harder and the exploration space is also moving deeper underground. So yes to all of those. Existing and future mines are shifting deeper underground.
Perhaps, Andrew, if you're still on the line, you may be able to address some of these questions about green and brownfield projects and a bit more about the resource that is known for some of BHP's assets. And
yeah, I'm still on. So yeah, just picking up on what Michelle spoke about. So yes, is the answer to have we identified the resources from a brownfields versus greenfields? Yes, we've got projects that we're looking at. So it's a big yes on the greenfields, but also there's applications at our current brownfields. We've got a number of operations that are open at depth, and so we still haven't got to the bottom of where the resource, the mineralization has gone to. So there's definitely applications at numerous operations, existing operations. So we have both brownfields and greenfields applications.
Great. Any other questions on the floor before we look to wrap up?
So I see the question around underground mineral processing technologies. Yeah, we are certainly looking at processing technologies. So yep. I think, yeah, as consider this as broad a search as sounds applicable to deep mining, but yeah, absolutely. We have a whole work stream looking at processing technologies.
And I think further to that as well, we recently had a comminution challenge that ended earlier this year, which has progressed to a cohort that worked on a desktop study of potentially integrating multiple different high TRL ideas from various startup businesses and potentially integrating elements of each of their technology together to build a business case for a higher capital final comminution technology. So there's been some extensive work, particularly in collaboration with Sedgman on this previously, but definitely looking at, interested in whatever ideas you have, especially in a deep mining context. That comminution challenge was focused on mineral processing in the surface, big processing plants. So different ways to approach it in a deep underground environment to assist the material movement is definitely of high value.
There's a question there, Sam, on what is our thoughts on maximum depth. I think in the challenge details where we sort of talk about a 2.5 kilometer depth. But if if anybody has watched the evolution of the South African mining, you'll know that it has grown from the initial depth. So I would sort of consider 2.5 kilometers as almost like a minimum starting point. We are, I think, as a society, are going to realize deeper and deeper. And I think in the South African contents, we're already down to a 4-kilometer plus depth. So yeah, hopefully that answers that question.
I've got a question. Have graph neutral network models been used in mining production forecasting and optimization?
There has. Have we done enough in this area? Probably not. I think it's definitely an emerging sort of area, but yeah, we have done work, and there are companies that we are working with and we have worked with that have also leveraged these types of approaches. But it's still, I think there's more to do in that area.
Yeah, I'd love to take this last one, Sam, if that's...
Yeah, sure.
So one challenge is applying oil and gas technologies to mining and having the opportunity to trial those opportunities. So we have a whole team set up within the Think and Act Differently team that is focused specifically on facilitating pilots, small and large scale pilots of technologies, either within our assets or, with third-party sites, depending on how mature they are. Openly, one of the issues that we've had with oil and gas technologies to date is, mining definitely works on a lower cost basis than oil and gas, and so that's been something of a challenge. But yes, we do have absolutely the team here that is focused on not just finding technologies, but how do we actually adopt those technologies? How do we facilitate the adoption of those technologies into our business as usual work streams?
Thanks, Michelle. Hopefully this deep mining challenge is one of multiple avenues that we're trying to open up to help fast track these opportunities to trial technologies on site. Thank you, everyone, for coming along and hearing from our external internal experts today. And if you're eager to get involved, feel free to get in touch with myself and join the Unearth platform, and we can continue the discussion. Thanks, everyone, for joining today.